Okay, so here's problem 2 from the practice quiz that I gave you guys. We're going to drop a penny from the top of the Empire State Building. So here's my penny. It's going to fall all the way to the ground. And we want to know two things. We want to know what speed it hit the ground with. So the impact speed is always going to be VF. And we want to know the time it would take to reach the ground. We're going to find time first because of the fact that when we drop something, VI is 0, the time you can always find by taking the square root of 2d over g for something in free fall. So if we work that out, we get the square root of 2 times 448.7 meters over 10 meters per second squared, and we get a time to fall of 9.47 seconds. Because the final velocity, initial velocity is 0, finding the final velocity is actually really easy. We're just going to do g times t because we're not adding initial velocity to it. So we'll do 10 meters per second squared times 9.47 seconds. So we get a final velocity of 94.7 meters per second. So that's the first part. Pretty straightforward, pretty easy, just something falling and dropping. The second part is going to change slightly. Instead of falling all the way to the ground, now 45.5 meters above the ground, that penny is actually going to come to a stop by hitting a pigeon right here, and the penny is going to get stuck inside the pigeon. I know it's a little weird and strange, but just kind of proving physics concept here. So no pigeons were actually hurt in the process of making this problem, I promise you guys. So the distance is now changed. The distance in this case, the penny's not going to fall all 448.7 meters. It's going to fall 448.7 meters minus the 45.5 meters that the pigeon is up in the air, which would give us a distance of falling of only 403.2. Okay, how's that going to help us? Well, we need to know the rate of acceleration. We are told that the penny eventually comes to a stop in the pigeon, so the final velocity is going to be 0. We were told the time of the collision is 0.425 seconds. We need to know the rate of acceleration of the penny in the pigeon. So what do we need to know? Well, we need to find VI somehow, because A is VF minus VI over t. So we need VI. How are we going to find VI? Well, VI is the exact same, VI for the contact point of the pigeon, is the exact same as VF for the drop. So when it hits the pigeon, that impact speed, that VF, is what we are looking for. That's also going to be our VI. So when we know a distance for something dropped, we can find VF by taking the square root of 2 times g times d. So we're going to have the square root of 2 times 10 meters per second squared times our distance, which is only 403.2 meters. If we work that out, we find out that the velocity at impact is 89.8 meters per second. So that's our final velocity of falling. It turns out that that switches to my initial velocity at impact. The final velocity after impact is 0. The penny is not moving once it hits the pigeon. The initial velocity the penny was moving at is 89.8. The time of the collision is 0.425 seconds. So now we have the acceleration just by solving 89.8 divided by 0.425, and we get a rate of acceleration of negative 211 meters per second squared. It might seem high, but remember that this penny is actually coming to a stop pretty quickly in a very short amount of time. So hopefully these two problems were some additional help for you guys. If you have any other questions, please email me and let me know.